Today we're going to talk about using the guess and check method of solving equations. I have given you an equation, m times parentheses m subtract 1 equals 306. So what number could I put in for m, and when I multiply it by a number that's one smaller than that number m, I will get 306. Sometimes when we're doing guess and check, it's a good idea to make a chart just to fill in what we find. So first we'll pick some values for m, and then we'll go ahead and write down what would m minus 1 equal, and then what would the answer to m times m minus 1 equal. Also, some people make an extra column for comments. If you want to comment, oh, too high, too low, whatever your answer comes out. We'll make a couple, but that's not really necessary. All right, well, if I'm multiplying two numbers and I'm getting 306, I know I'm not going to use small numbers. So we are just guessing here. Let's suppose we picked 10 and 11. So if m is 11, 11 subtract 1 is 10. So I'm actually multiplying 10 times 11. Some of you can do that in your head. When you multiply by 10, it just adds a 0 on the end of the other number. So 11 times 10 is just 110. That's too low. So if you want to make a comment, that is too low. We're supposed to get two numbers that when we multiply them, we get 306. So let's jump up. Let's maybe try 15 and 16. So if m is 16, 16 subtract 1 would give us our 15. That's our 15 and 16. So what is 15 times 16? Well, 5 times 6 is 30. 5 times 1 is 5, and 3 more makes 8. 1 times 6 is 6. 1 times 1 is 1. When we add this up, 8 plus 6 is 14. Carry your 1. 1 and 1 is 2. 240. Still too low. Too low. So we got 240 when we multiplied those two. But we are a lot closer to 306 than the 10 and 11. So maybe we should try 16 and 17. So if m is 17, 17 subtract 1 is 16. 17 times 16. And again, we have to come over to the side and multiply. 6 times 7 is 42, carry your 4. 6 times 1 is 6, and 4 more makes 10. Okay, and now we're multiplying by 1. Actually, of course, we're multiplying by 10. So if you want to put that placeholder there, you can. 1 times 7 is 7. 1 times 1 is 1. We end up with 272. Wow, we are getting closer. Again, if you want to make your comment, it's too low. I'm just putting ditto marks, same answer. All right, well, maybe we should try 17 and 18. Okay, so if this is 18, this would be 17. Okay, let's multiply 18 times 17. Okay, 7 times 8 is 56, carry your 5. 7 times 1 is 7, plus 5 more makes 12. Again, we're actually multiplying by 10 here, so there's a 0. 1 times 8 is 8. 1 times 1 is 1. We add them together. 6, 8, and 2 is 10. Carry your 1. 1, 2, 3. Yay, we found it. 306. So, again, this is the guess and check method. We just checked numbers until we found the pair that worked to give us 306. So, again, if m was 18, then we would say 18 times 18 subtract 1 equals 306. 18 subtract 1, of course, is 17. So 18 times 17, and we just checked it over here. 18 times 17 gives us 306. So that's our answer. Suppose we had the problem of finding the area of a rectangle, and we were told that the width and length to have this comparison. The length is 3 times as long as the width, so we'll just say W is our width. The length is 3 times as long. Now, if they told us that the square footage of this rectangle is 147 feet squared, the question is, what are the length and the width of this? Well, again, we could make a chart. We could we need to pick a value for W, and then we'll have a value for 3W, and then we will multiply these two, because to find the area, you multiply the length times the width. And then we can make another column for comments if we want to comment about whether our value is too high or too low. Since 147 is a pretty good size number, and we're only multiplying 3W times W, let's maybe start out with 10. If W was 10, 3 times 10 is 30. But if we multiplied 30 times 10, we would get 300. And of course, that is too big or too high. It's not near the number 147. But when I look at 147 and I look at 300, I think, 147 is half of 300. So why don't we try 5 this time? Let's try 5 for W, and 3 times 5 is 15. Okay, let's multiply that. 15 times 5. 5 times 5 is 25. 5 times 1 is 5, and 2 is 7. 75. Too low. So we're going to have to find another number. Well, maybe what's halfway between 5 and 10. Let's try 8 this time. Of course, we can make our chart as big as we need to. We'll make 8 this time. And then 3 times 8 is 24. Okay, let's try those two. 24 times 8. 4 times 8 is 32, carry your 3. 2 times 8 is 16, and 3 is 19. 192. Oh, too high. Okay, so we're doing guess and check here. Maybe we should try 7. And then 3 times 7 is 21. Let's try that. 21 times 7. 7 times 1 is 7. 7 times 2 is 14. Yay, we found it. 147. So again, using guess and check, we found the exact pair that works. This time I'm going to give you a puzzle and let you come up with an equation. What if I said twice a number plus 6 is equal to 4 times the same number? All right, let's see if we can put that into an equation. I said twice a number, and that would be 2 times n, plus 6 is equal to 4 times the number. Okay, we're going to use guess and check to try to figure out what that number is. Sometimes when we are just an equation that's very random like this, it's almost easier just to start with 1 and go up. So I think on our chart that's what we'll do. First of all, we're going to pick a value for n, and then we're going to find out what is 2 times n plus 6, and then we're going to find out what is 4 times n, and then we'll know if our values are equal to each other. Okay, so here's our little chart we're making. Okay. All right, let's start with the number 1. 2 times 1 is 2. 2 plus 6 is 8. 4 times 1 is 4. Does 8 equal 4? No. So, again, see, I don't know if you want to do comments on this. They're not equal. I'm just going to say no. All right, let's try 2. 2 times 2 is 4. 4 plus 6 is 10. 4 times 2 is 8. Ooh, we're getting closer. So I'm going to write closer because 10 and 8 are closer than 8 and 4. So let's try 3. 2 times 3 is 6. 6 plus 6 is 12. 4 times 3 is 12. Yay, we found it. Okay. So again, we used a chart and we used guess and check to find our answer. This is a word problem that involves 2 students, Joe and Susie. And whenever we have lots of information, it's great to label, make a heading. Joe and Susie went to the mall, and we're told that Joe bought 3 cookies and he spent $3.25 on a latte. Now we don't know the price of the cookie, so let's write this down. He bought 3 cookies, 3 times the price of a cookie. We'll say the price of the cookie is C, plus he spent $3.25 on a latte. Susie bought 2 cookies, so it's 2 times the cost of the cookie, plus she found a CD on sale on a clearance for $5, so she spent $5 on a CD. Now, they spent the same amount of money. So I can make an equation. I could say that these 2 amounts are equal to each other because they spent the same amount of money. That means 3 times C plus 3.25 equals 2 times C plus $5. Okay. Now, again, we need to make a chart so that we can compare these. So we're going to pick a value for C, and then we're going to come up with a value of 3C plus 3.25, and we're going to compare that with 2C plus 5. Okay, so here's our chart, and this time I think I'm just going to use my calculator. All right, suppose we started out, let's start with a 1. Let's say the cookie cost $1. All right, so when I plug in 1 into the C, 3 times 1 is 3. 3 plus 3.25 is 6.25. That one's easy to do in your head. Over here, when I fill in 1 for C, 2 times 1 is 2. 2 plus 5 is 7. So this time, I think instead of making comments, I'm going to make the difference. These 2 are supposed to be the same, remember. It said they spent the same amount of money. But here, I see that there's a difference of 75 cents. So I'm 75 cents off from making them the same amount, spending the same amount. So maybe I'll go up a little. I'll say, well, let's suppose the cookie cost $1.25. Let's see if I can get these 2 amounts to be the same. Here's where I'm going to use my calculator. When I plug in $1.25 times 3 and add 3.25, I come up